Here we'll talk about the domain and range of radical graphs, or also known as square root functions. Our first graph on the left is y equals square root of x. When you examine this graph, you may notice the entire left side of the graph seems to be blank. Notice also the graph appears to begin at 0. We know from previous videos if we try to take the square root of a negative number, we end up with a complex answer involving the letter I. Now, on a standard x and y graph that you'll use for Math 171, you will not see complex answers on the graph, and we don't graph them at all. Therefore, for the purposes of Math 171, when it comes to graphs, everything under the root must be positive or 0, but cannot be negative. Therefore, where the domain is concerned, the graph only begins at 0. Again, that's because if we went any lower, we would be taking the square root of a negative number, which is complex and is not visible on this graph. Now, this graph starts out by going upward and to the right, and so we will have a right arrow. So where domain is concerned, right arrows mean infinity. So we'll say our domain for this function is from 0 to infinity. Also notice that at 0 we do have a closed dot. And for closed dots, you'll represent that with square brackets in your domain and range, meaning that point is included in the domain or range. So we'll put a square bracket around 0 and parentheses around infinity, because infinity isn't a number, it will always have parentheses. Now if we look to the range, we can see that our closed dot also has a y value at 0. And we can also see our right arrow is diagonal and seems to be going upward, albeit slowly. Since we have an up arrow where range is concerned, that symbolizes infinity. So our range is also 0 to infinity, also with a square bracket on 0. Now if we're trying to find f at 4, let's first locate 4 on the x-axis, draw a dot at that position on the graph, and then have a look at what y value we end up with. Our y value appears to be 2, and so we'll say f at 4 is 2. We could also find this algebraically. If y is equal to square root of x, and our x is 4, we can say y is equal to square root 4. But the square root of 4 is 2, and we get the same answer algebraically. My graph on the right says y is equal to square root of x plus 2. And notice that our dot is in a different position. That plus 2 appears to have shifted us to the left. We originally started at 0, but that plus 2 has moved our starting point over 2 spaces to negative 2. Effectively, we've shifted the entire graph left by 2. We'll also prove that this works algebraically in a future video. For now, let's examine the graph and look to the domain. Our start point is x equals negative 2, and we also have a right arrow. Where the domain is concerned, that symbolizes infinity. So we can say our domain goes from negative 2 to infinity, with negative 2 in the square bracket because we have a closed dot. Now let's examine our range. Let's look to our y value at this dot. We can see that we're directly on the axis, and so y would be equal to 0. And again, this arrow is going slightly upward, so we also have an up arrow, which symbolizes infinity when we're looking to the range. Therefore, we'll say our range is 0 to infinity. Infinity with a parentheses, 0 with a square bracket. Once again, let's look for f at 2. Locate 2 on the x-axis, draw a dot, and then read the y value. We can see that our y value at that position where I've placed the dot is 2. So we'll say f at 2 is equal to 2. Again, if we want to do this algebraically, we could say y is equal to square root of x plus 2. If x was 2, we'd have y equals square root of 2 plus 2, but 2 plus 2 is 4, And we already found previously that the square root of 4 is 2. This is how we find domain and range of radical functions.